Hello students, welcome to this lecture, Burn Straight Lines. So in this lecture, we will discuss NCERT exercise 9.1. So this is disclaimer. So today, we will cover NCERT exercise 9.1. So first of all, make sure you have your notebooks and pens ready. So first of all, let us take a look at first question. So here in this question, we have given draw a quadrilateral in the Cartesian plane whose vertices are minus 4, 5, 0, 7, 5, minus 5, and minus 4, minus 2. And then we have to also find its area. Okay. So first of all, draw a quadrilateral in the Cartesian plane and whose vertices are given here. And then we have to find its area. So students, first of all, try it yourself. Okay. And then see the solution. So you have 40 seconds to solve this problem and then we will provide the solution. Okay, students, your time is over. So now we will see how to solve it. So what informations are given? First look at that. So we have given information. Basically, we have to draw a quadrilateral in the Cartesian plane. Okay. Whose vertices are given here? Minus 4, 5, 0, 7, 5, minus 5, and minus 4, minus 2. Okay. And then we have to also find its area. So let us see solution. So first of all, we let here A, B, C, D be the given quadrilateral with vertices A minus 4, 5, B 0, 7, C 5, minus 5, and D minus 4, minus 2. Okay. So first let A, B, C, D be the given quadrilateral. Okay. Whose vertices are given here. A, B, C, and D. So then by plotting A, B, C, and D on the Cartesian plane and joining AB, BC, CD, and DA. So the given quadrilateral can be drawn as follows. So here you can see in below figure. So this is basically our quadrilateral with vertices A, B, C, and D. So to find the area of quadrilateral ABCD, first of all, we have to draw one diagonal. Okay. Say AC. So here we have drawn here AC as a diagonal of the quadrilateral ABCD. So accordingly, area of quadrilateral ABCD is basically equal to area of triangle ABC plus area of triangle ACD. Okay. So area of quadrilateral ABCD is nothing but sum of area of triangle ABC and triangle ACD. Okay, area of triangle ACD. So we know that the area of the triangle whose vertices are x1, y1, x2, y2, and x3, y3 is. So we all know the area of a triangle whose vertices are given. Okay, is basically 1/2 modulus value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay. So it is known that the area of a triangle whose vertices are x1, y1, x2, y2, and x3, y3 is this one. Okay. So this is the formula for the area of a triangle whose vertices are given. So points are here minus A minus 4 comma 5, B 0 comma 7, and C 5 comma minus 5. Okay, so these points are given to us in our given question. So therefore, area of triangle ABC is what? So if we put the values of x1 comma y1, x2 comma y2, and x3 comma y3, okay, x1 comma y1 is minus 4 comma 5, x2 comma y2 is basically 0 comma 7, and x3 comma y3 is basically 5 comma minus 5. Okay, so if we substituting the value of x1 comma y1, x2 comma y2, and x3 comma y3 in the above formula, area of the triangle formula, okay, then we will get area of triangle ABC is equal to 1 by 2 modulus value of minus 4 into 7 plus 5 plus 0 into minus 5 minus 5 plus 5 into 5 minus 7 square unit. Okay, so now simplify it, then you will get this one. So 1 by 2 modulus value of minus 4 into 12 plus 5 into minus 2 square unit. Okay, and this is equal to 1 by 2 modulus value of minus 48 minus 10 square unit. So after calculation, we will get area of triangle ABC. This is equal to 1 by 2 modulus value of minus 58 square unit. So therefore, this is equal to 1 by 2 times 58 square unit. And this is equal to 29 square unit. And we know that the area of a triangle whose vertices are x1 comma y1, x2 comma y2, and x3 comma y3 is 1 by 2 modulus value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, this formula is very important formula for finding area of a triangle whose vertices are given. Okay, so you should keep in your mind this formula. So here points are basically A minus 4 comma 5, C 5 comma minus 5, and D minus 4 comma minus 2. So what we are going to do? So here we are going to find the area of triangle ACD. Okay, so here are the vertices A, C, and D are given. Okay, so now area of triangle ACD is what? So area of triangle ACD, this is equal to 1 by 2 modulus value of minus 4 times minus 5 plus 2 plus 5 times minus 2 minus 5 plus minus 4 times 5 plus 5 square unit. Okay, so basically here we substitute the value of x1 comma y1 as minus 4 comma 5 and x2 comma y2 as 5 comma minus 5 and x3 comma y3 as minus 4 comma minus 2. So now calculate it. So if we simplify it, then you will get this one, 1 by 2 modulus value of minus 4 into minus 3 plus 5 into minus 7 minus 4 into 10 square unit. So area of triangle ACD is this is equal to basically 1 by 2 modulus of 12 minus 35 minus 40 square unit. Okay, and this is equal to 1 by 2 modulus value of minus 63 square unit. And this is equal to 63 over 2 square unit. Okay, so area of triangle ACD is this is equal to 63 over 2 square unit. So since we know area of quadrilateral ABCD is basically sum of area of triangle ABC and area of triangle ACD. Okay, and we have found the area of triangle ABC is 29 square unit and area of triangle ACD is 63 over 2. So therefore, area of quadrilateral ABCD is basically equal to 29 plus 63 over 2 square unit. So if we simplify it, then you will get this is equal to 58 plus 63 over 2 square unit. So therefore, required area, this is equal to 121 divided by 2 square unit. Okay, so therefore, the area of the quadrilateral in the Cartesian plane whose vertices are given minus 4 comma 5, 0 comma 7, 5 comma minus 5 and minus 4 comma minus 2. This is basically equal to 121 over 2 square unit. Okay, and this is the final answer. I hope it is clear to all of you. So solution of this question is very simple. Okay. So now let us move to next problem. So in next problem, here first of all see what informations are given. Okay, and try to understand what want to say this problem. So the face of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at the origin. Okay, and then find the vertices of the triangle. So students, first of all, try to solve this problem and then we will provide the solution. So you have 40 seconds to try to solve this problem and then we will provide the solution. Okay, students, your time is over. So now we will see how to solve this question. So let us see solution. So base of the triangle along the y-axis. Okay, his side length of the equilateral triangle is 2a. Okay, so we have an equilateral triangle. Side length of that equilateral triangle is basically 2 times a, and the base lies along the y-axis here. At the midpoint of the base is at the origin 0, 0. Okay, so note these informations. These informations will help us to solve this question. So first of all, we let the base be between points A and B on the y-axis. So see this figure. So you can see here in this figure, AB. Okay, AB is basically base of this triangle and base lies along the y-axis here. Okay, and now we have to find the coordinates of A and B and C. Okay, so side since the length is here 2a. Okay, this length is basically 2a and the midpoint is at the origin here. So what are the coordinates of A? So the coordinates of A are basically 0, a. Okay, and what are the coordinates of B? So the coordinates of B are 0, minus a here. Why this is? Because here you can see this this length of this side is basically 2a. Okay, and here the midpoint of the base is at the origin 0, 0. Okay, so the coordinate of A point are basically 0, a, and the coordinate of B point are 0, minus a. So let here the third vertex be C. Okay, C is equal to x, 0, and since it must be symmetric with respect to y-axis, so C point basically lies along the x-axis. Okay, and here we let the third vertex of the triangle C equal to x, 0. So using distance formula here, so note this formula. So if you have 2 points x1, y1 and x2, y2, then distance formula for these 2 points is basically square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so you should note this formula. This formula will help us to solve this example. So distance from C x, 0 to A 0, a should be here 2a. Okay, So CA is basically equal to square root of x minus 0 whole square plus 0 minus a whole square. So distance between point C and A, this is equal to square root of x minus 0 whole square plus 0 minus a whole square. And this should be 2a. So square root of x minus 0 whole square plus 0 minus a whole square, this is equal to 2 into a. So squaring in both sides for finding the value of x. So now squaring both sides in this equation, then what we will get? Then we get x square plus 0 minus a whole square. This is equal to 2a whole square. And from this equation, we will get x square plus a square. This is equal to 4 times a square. Okay, and then simplify further, then you will get x square. This is equal to 3 times a square. And now when taking square root in both sides, we get x, this is equal to plus minus square root of root 3 times a. So therefore, coordinates of the point C is basically plus minus root 3a comma 0. Okay, so the coordinates of the point C are basically plus minus root 3 times a comma 0. So see this figure. Okay, so here you can see this is actually equilateral triangle here. So thus the vertices of the given equilateral triangle are 0 comma a. Okay, this coordinate is 0 comma a. This the coordinate of B point are basically 0 comma minus a, and the coordinate of the point C are root 3 plus minus root 3a comma 0. Okay, so we can first take root 3a comma 0, this coordinate. Okay, so the vertices of the given equilateral triangle are basically 0 comma a comma 0 comma minus a and root 3a comma 0, or 0 comma a comma 0 comma minus a and minus root 3a comma 0. Okay, so the vertices of the triangle are 0 comma a comma 0 comma minus a and root 3a comma 0, or 0 comma a 0 comma minus a and minus root 3a comma 0. Okay, so this is very simple. So I hope it is clear to all of you. So now let us move to next question. So in next question, here we have to find the distance between the point x, point P x1 comma y1 and Q x2 comma y2 when PQ is parallel to the y-axis. Okay, and next PQ is parallel to the x-axis. So we have to find the distance between these 2 points. Okay, P and Q. And we have given condition PQ. First condition we have given here, PQ is parallel to the y-axis. Okay, and the second condition we have given, PQ is parallel to the x-axis. So students, first of all, try it yourself and then the solution. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, student, your time is over. So now we will see how to solve this question. So first of all, try to understand this question. So in this question, we have to find the distance between P x1 comma y1 and Q x2 comma y2. Okay, when PQ is parallel to the y-axis, okay, and PQ is parallel to the x-axis. So let us see solution. So the given points are basically P x1 comma y1 and Q x2 comma y2. Okay, these 2 points are given to us. And when PQ is parallel to the y-axis, So when PQ is parallel to y-axis, then x coordinate of both points will equal. Okay, that means x1 equal to x2. So when PQ is parallel to the y-axis, then x1 this is equal to x2. So in this case, distance between P and Q is basically square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so it is known that distance between 2 point P x1 comma y1 and Q x2 comma y2 is basically this is basically equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so in this case, here you can see x1 this is equal to x2. So we will get this is equal to square root of y2 minus y1 whole square, because here x1 equal to x2. So x2 minus x1 whole square, this will become 0. Okay, so we will get distance between P and Q. This is equal to square root of y2 minus y1 whole square. So now we can write it as modulus value of y2 minus y1. Okay, so if we out y2 minus y1 whole square root, then we can write this is as modulus value of y2 minus y1. So if PQ is parallel to the y-axis, then distance between P x1 comma y1 and Q x2 comma y2 is modulus of y2 minus y1. Okay, so in this case, simply you have to take modulus value of difference of y2 and y1. Okay, so this will give us distance between the point P and Q. So hence, distance when PQ is parallel to the y-axis is basically modulus value of y2 minus y1. So point to be noted here. So if PQ, this line segment is parallel to the axis y-axis, then distance between PQ is basically equal to modulus of y2 minus y1. So the given points are here P x1 comma y1 and Q x2 comma y2 here. And when PQ is parallel to the x-axis, so when PQ is parallel to the x-axis, that case y coordinates of P and Q will be equal. Okay, that means y1 equal to y2. When it will happen if PQ is parallel to the x-axis, that case y1 equal to y2. And in this case, distance between P and Q is basically equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, and since PQ is parallel to the x-axis, that is y1 equal to y2. So here the second term y1 minus y2 minus y1 whole square, it will be 0. Okay, so simply we will get the distance between P and Q. This is equal to square root of x2 minus x1 whole square. Okay, and this is equal to modulus value of x2 minus x1. So the distance between P and Q, this is equal to modulus of x2 minus x1. When it will if the PQ, okay, if PQ is parallel to the x-axis, then in this case, distance between P and Q, this is equal to modulus of x2 minus x1. Hence, distance when PQ is parallel to the x-axis, this is equal to modulus of x2 minus x1. So what you have to remember? So you should remember, when PQ is parallel to the y-axis, then the distance between P and Q is modulus of y2 minus y1. And when PQ is parallel to the x-axis, then distance between P and Q is modulus of x2 minus x1. Okay, these 2 points you should remember. So now let us see question number 4. So in this question, what we have to do and what informations are given. Okay, let's try to understand. So find a point on the x-axis. So we have to find here a point on the x-axis, which is equidistant from the points 7, 6 and 3 comma 4. Okay, this condition we have given. So we have to find a point on the x-axis. Okay, and that point is equidistant from the points 7 comma 6 and 3 comma 4. Okay, that means if we find distance between a point on the x-axis and 7 comma 6 and a point on the x-axis and 3 comma 4, then this will become equal. Okay, so this we have given here. So first of all, try it yourself and then see solution. So you have 40 seconds to try to solve this question and then we will provide the solution. Okay, students, your time is over. So now we will see how to solve this question. So let us see solution. Let a comma 0 be the point on the x-axis that is equidistant from the points 7 comma 6 and 3 comma 4. Okay, so first we suppose a comma 0, this point, be the point on the x-axis. Okay, and this point is equidistant from the points 7 comma 6 and 3 comma 4. And we have distance between the points p x1 comma y1 and q x2 comma y2 is basically square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so it is known that distance between p and q is pq equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So therefore, square root of 7 minus a whole square plus 6 minus 0 whole square, this is equal to square root of 3 minus a whole square plus 4 minus 0 whole square. Why? Because here you can see the point a comma 0 is a comma 0. This point is equidistant from the points 7 comma 6 and 3 comma 4. Okay, that means if we find distance between a comma 0 and 7 comma 6, and if we find distance between a comma 0 and 3 comma 4, then it will be equal. Okay, so we get this equation, square root of 7 minus a whole square plus 6 minus 0 whole square. This is equal to square root of 3 minus a whole square plus 4 minus 0 whole square. So now it's now simplify it. So or you will get square root of 49 plus a square minus 14a plus 36. This is equal to square root of 9 plus a square minus 6a plus 16. Okay, so what you will get, this is what square root of a square minus 14a plus 85. This is equal to square root of a square minus 6a plus 25. So one squaring both sides, then we get a square minus 14a plus 85. This is equal to a square minus 6a plus 25. Now calculate this equation. So, or you will get further simplification, minus 14a plus 6a. This is equal to 25 minus 85. Okay, or 8a minus 8a equal to minus 60. And 1 dividing by minus 8 in both sides, we get a equal to 60 over 8. Okay, and if we simplify it, then we will get the value of a is equal to 15 by 2. Hence the point on the x-axis is 15 by 2 comma 0. Okay, so if we find the stand between 15 by 2 comma 0 and 7 comma 6, okay, and then if we find the distance between 15 by 2 comma 0 and 3 comma 4, then these two distance will equal distance. Okay, so I hope it is clear to all of you. So now let us move to next question. So in this question, we have to find the slope of a line. which passes through the origin and the midpoint of the line segment joining the points P 0, -4 and B 8, 0. So what we have to do here? So we have to do here, we have to find the slope of a line. Okay, and we have given that line passes through the origin and the midpoint of the line segment joining the points P 0, -4 and B 8, 0. So students, first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students. So now let us see how to solve this question. So the coordinates of the midpoint of the line segment joining the points P 0, -4 and B 8, 0 are 0 plus 8 by 2, minus 4 plus 0 by 2. Okay, and this is equal to 4, minus 2. So the coordinates of the midpoint of the line segment joining the points P and B are basically 4, minus 2. So using this formula, m equal to y2 minus y1 divided by x2 minus x1, where x1 does not equal to x2, and where x1, y1 and x2, y2 are the points, and m is slope of the line. So note this formula. Therefore, the slope of the line passing through the point 0, 0 and 4, minus 2. So this is equal to minus 2, minus 0 divided over 4 minus 0. So we used here the above formula, m equal to y2 minus y1 divided by x2 minus x1. Okay, and then we obtain the slope of the line passing through the point 0, 0 and 4, minus 2 is minus 2, 0, minus 2, minus 0 divided over 4 minus 0. This is equal to minus of 1 by 2. Hence, the slope of the line is basically minus 1 by 2. Okay, so the slope of a line which passes through the origin and the midpoint of the line segment joining the points P 0, minus 4 and B 8, 0 is minus 1 by 2. Okay, and this is the final answer. So now let us move to the next question. So in next question here we have given without using the Pythagoras theorem. So we cannot use Pythagoras theorem to solve this to solve this question. Okay, so in this question we have to show that the points 4, 4, 3, 5 and minus 1, minus 1 are the vertices of a right angle triangle. Okay, so what we have to do here, we have to show here the given points 4, 4, 3, 5 and minus 1, minus 1 are the vertices of a right angled triangle. So students, first of all, try it yourself and then see solution. You have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, your time is over. So now let us see how to solve this question. So the vertices of the given triangle are A 4, 4, B 3, 5, and C minus 1, minus 1. Okay, so these are vertices of the given triangle. Using this formula, M equal to y2 minus y1 divided over x2 minus x1, where x1 does not equal to x2. Okay, where x1, y1 and x2, y2 are the points, and M, this is equal to slope of the line. So slope of AB, okay, M1, this is equal to basically 5 minus 4 divided over 3 minus 4. Okay, and if we calculate this, then you will get this is equal to minus 1. So slope of line AB, that is denoted here, M1, this is equal to minus 1. And slope of line BC, M2, this is equal to minus 1, minus 5 divided over minus 1, minus 3. And this is equal to minus 6 over minus 4. Okay, and this is equal to 3 by 2. Clear? And slope of CA, M3, this is equal to 4 plus 1 divided over 4 plus 1. And this is equal to 5 over 5. Okay, and if we cancel this, then you will get this is equal to 1. So slope of CA, that is denoted here, M3, this is equal to 1. So it is observed that product of M1 and M3 is minus 1. Okay, so the slope of product of slope of AB and slope of CA, this is equal to minus 1 here. So therefore the line segments AB and CA are perpendicular to each other. Okay, so as we studied in our previous lecture, if product of slope is minus 1, then the lines are perpendicular to each other. Okay, so the line segments here are AB and CA are perpendicular to each other. So that is the given triangle is right angled at A what is 4, 4. Okay, so the angle A is basically here 90 degree. So the given triangle whose vertices are given here 4, 4, 3, 5 and minus 1, minus 1 is basically right angled. Thus the points 4, 4, 3, 5 and 1, 1 are the vertices of a right angled triangle. Okay, so it is shown that the points 4, 4, 3, 5 and minus 1, minus 1 are the vertices of a right angled triangle. Okay, so now let us move to next question. So in next question, here we have to find the slope of the line which makes an angle of 30 degree with the positive direction of y-axis measured anti-clockwise. Okay, so we have to find here slope of the line. That line makes an angle of 30 degree with the positive direction of y-axis and measured here anti-clockwise. Okay, so students, first of all, try it yourself and answer it. So you have 40 seconds to solve this question and then we will provide the solution. Okay, students, so now let us see how to solve this question. So if a line makes an angle of 30 degree with the positive direction of y-axis measured anti-clockwise, then the angle made by the line with the positive direction of the x-axis measured anti-clockwise is basically 90 degree plus 30 degree. So that is equal to 120 degree. So here a 120 degree is basically the angle made by the line with the positive direction of the x-axis measured anti-clockwise. Okay, so using here m equal to tan theta, where theta is not equal to 90 degree, and where m is slope and theta is inclination of a line. Okay, and we have found the slope, the inclination of a line, theta is basically 120 degree in above. So thus the slope of the given line is what? So what is the slope of the given line? So the slope of the given line is basically equal to tan 120 degree. So now you can find out the value of tan 120 degree easily. So you can write tan 120 degree as tan of 180 degree minus 60 degree. And as we know, tan of 180 degree minus theta is basically minus tan theta. So tan 180 degree minus 60 degree, this is equal to basically minus tan 60 degree. Okay, and the value of tan 60 degree is basically root 3. So tan 180 degree, this is equal to minus root 3. Hence, required slope is minus root 3. Okay, so the slope of the line which makes an angle of 30 degree with the positive direction of y-axis measured anti-clockwise is minus root 3. Okay, clear? I think it is clear to all of you. So now let us move to next question. So in this question, here we have to show that points minus 2, minus 1, 4, 0, 3, 3, and minus 3, 2 are the vertices of a parallelogram. Okay, without using distance formula. So here we cannot use the distance formula. Without using distance formula, we have to show that these points are the vertices of a parallelogram. Okay, so students, first of all, try it yourself and then the solution. So you have 40 seconds to solve this question and then we will provide the solution. Okay, students, now we will see how to solve this question. So let points minus 2, minus 1, 4, 0, 3, 3, and minus 3, 2 be respectively denoted by A, B, C, and D. Okay, and draw this diagram. So here we will get this this diagram. This diagram is basically parallelogram. Okay, and basically we have to show the points minus 2, minus 1, 4, 0, 3, 3, and minus 3, 2 are the vertices of a parallelogram. So using here m, this is equal to y2 minus y1 divided over x2 minus x1, where x1 does not equal to x2 and x1 y1 and x2 y2 are the points and m is basically slope of the line. And slope of AB is basically 0 plus 1 divided over 4 plus 2, and this is equal to 1 by 6. So we use here this formula m equal to y2 minus y1 divided over x2 minus x1. Okay, and then substituting the value of minus 2, minus 1 and 4, 0. Then we got the slope of the line segment AB is 1 by 6. And the slope of CD is basically 2 minus 3 divided over minus 3 minus 3. Okay, and this is equal to minus 1 over minus 6, and this is equal to 1 by 6. Slope of CD is basically 1 by 6. Therefore, slope of AB is equal to basically slope of CD. And AB and CD are parallel to each other. Okay. So see this figure. So here we have shown here slope of AB, this is equal to slope of CD. Okay, and we know if their slopes are equal. Okay, if we have two lines and if their slopes are equal, then both lines are parallel to each other. So here AB and CD are parallel to each other. So using this formula y2 minus y1 divided over x2 minus x1, where x1 does not equal to x2, where x1 comma y1 and x2 comma y2 are the points and m is slope of the line. So now slope of BC is 3 minus 0 divided over 3 minus 4. Okay, and this is equal to 3 over minus 1, and this is equal to minus 3. So slope of BC is minus 3, and slope of AD is 2 plus 1 divided over minus 3 plus 2. This is equal to 3 over minus 1. This is equal to minus 3. Okay, so here you can see slope of BC and slope of AD are equal. So therefore slope of BC, this is equal to slope of AD. So BC and AD are parallel to each other. So therefore both pairs of opposite sides of quadrilateral ABCD are parallel here. So hence ABCD is a parallelogram. Okay, so for being parallelogram, both pairs of opposite sides should be parallel. Okay, so here we have shown both pairs of opposite sides of the quadrilaterals ABCD are parallel. So ABCD is a parallelogram. So thus points minus 2 comma minus 1, 4 comma 0, 3 comma 3 and minus 3 comma 2 are the vertices of a parallelogram. Okay, proved. So I hope it is clear to all of you. So now let us move to next question. So in next question here we have to find the angle between the x-axis and the line joining the points 3 comma minus 1 and 4 comma minus 2. So students, first of all try it yourself and then the solution. So you have 40 seconds to solve this question and then we will provide the solution. Okay students, now see how to solve this question. So using this formula, m, this is equal to y2 minus y1 divided over x2 minus x1, where x1 does not equal to x2. Okay, so if x1 equal to x2, then this function, the m equal to y2 minus y1 divided over x2 minus x1 will be undefined. Okay, so that is why here x1 does not equal to x2, and where x1 comma y1 and x2 comma y2 are the points and m is slope of the line. So slope of the line joining the points 3 comma minus 1 and 4 comma minus 2 is basically m equal to minus 2 minus of minus 1 divided over 4 minus 3. Okay, and this is equal to minus 2 plus 1. This is equal to minus 1. Okay, so slope of the line joining the points 3 comma minus 1 and 4 comma minus 2 is minus 1. And using this formula, m equal to tan theta, where theta is not equal to 90 degree, because if we take theta is 90 degree, then tan 90 degree will be undefined. Okay, that is why here we take theta does not equal to 90 degree, where m is slope and theta is inclination of a line. So now the inclination theta of the line joining the points 3 comma minus 1 and 4 comma minus 2 is given by tan theta. This is equal to minus 1. Okay, and it implies theta is 135. Okay, so you can find tan theta. This is basically equal to tan of 180 degree minus 45 degree. Okay, and from there you will get theta is equal to 135 degree. Thus the angle between the x-axis and the line joining the points 3 comma minus 1 and 4 comma minus 2 is 135 degree. So the angle between the x-axis and the line joining the points 3 comma minus 1 and 4 comma minus 2 is 135 degree, and this is the final answer. So we use this formula, m equal to y2 minus y1 divided over x2 minus x1, and we then next we used here m equal to tan theta. Okay, and then we got our answer. Okay, here the final answer is 135 degree. So now let us move to next question. So in next question here, we have given the slope of a line is double of the slope of another line. If tangent of the angle between them is 1/3, find the slope of the lines. Okay, so we have given some informations. Okay, and then we have to find the slopes of the lines. So what informations are given here? So slope of a line is double of the slope of another line. Okay, slope of one line is double of the another line, and here we have given if tangent of the line angle between them is 1/3. Okay, then we have to find slopes of the lines. So students, first of all, try it yourself and then see solution. So you have for 50 seconds to solve this question, and then we will provide the solution. Okay, students. So now let us see how to solve this question. So here we have to find the slopes of the lines. So let M1 and M be the slopes of the two given lines such that M1 is equal to 2 times M. Okay, since the slope of a line is double of the slope of the another line. Okay, and here we let M1 and M be the slopes of the two given lines such that M1 this is equal to 2 times M. So we know that if theta is the angle between the lines L1 and L2 with slopes M1 and M2, then tan theta is what? Then tan theta this is equal to modulus value of M2 minus M1 divided over 1 plus M1 into M2. Okay. So if theta is the angle between two lines L1 and L2 with slopes M1 and M2, then tan theta this is equal to modulus value of M2 minus M1 divided over 1 plus M1 into M2. Okay. So you should remember this formula. So it is given that the tangent of the angle between the two lines is 1/3. Okay. So therefore 1/3 this is equal to modulus of m minus 2m divided over 1 plus 2m times m. Using here m is equal to tan theta. Okay. And theta is not equal to 90 degree, where m is slope and theta is inclination of a line. Or you can simplify it, then you will get this is 1/3 this is equal to modulus of minus m divided over 1 plus 2m square. Or 1/3 this is equal to minus m over 1 plus 2m square, or 1/3 equal to minus of minus m divided over 1 plus 2m square, and minus of minus m over 1 plus 2m square this is equal to basically m over 1 plus 2m square. So now case 1, 1/3 this is equal to minus m divided over 1 plus 2m square. So take this equation and then solve this. So, or you will get this equation 1 plus 2m square this is equal to minus 3m, or 1 plus 2m square plus 3m this is equal to 0. Or you can rearrange this equation as 2m square plus 3m plus 1 this is equal to 0. Or you can now you can do it here. You can factorize this quadratic equation by using middle term factor. So you can write this equation as 2m square plus 2m plus m plus 1 this is equal to 0. And then you will get 2m times m plus 1 plus 1 times m plus 1 this is equal to 0. So you will get this equation m plus 1 times 2m plus 1 this is equal to 0. So from this equation you will get two values of m. One value is minus 1 and other value is minus 1/2. If m is minus 1, then slopes of the lines are basically minus 1 and minus 2. Okay. And if m is minus 1 by 2, then slopes of the lines are basically minus 1 by 2 and minus 1. And now take case 2. 1 by 3, this is equal to m over 1 plus 2m square. So now 1 multiplying cross, now 1 cross multiplying, you will get 2m square plus 1, this is equal to 3m. And then if we rearrange the above equation, then you will get 2m square minus 3m plus 1, this is equal to 0. And now using middle term factoring, okay, then you can write the above equation as 2m square minus 2m minus m plus 1, this is equal to 0. Or 2m times m minus 1 minus 1 times m minus 1, this is equal to 0. Or m minus 1 times 2m minus 1, this is equal to 0. And now you will get the value of m is 1 or m is 1 by 2. Okay. If m is 1, then the slopes of the lines are 1 and 2. If m is 1 by 2, then the slopes of the lines are 1 by 2 and 1. Hence, the slopes of the lines are basically minus 1 and minus 2, or minus 1 by 2 and minus 1, or 1 and 2, or 1 by 2 and 1. Okay. And this is the final answer. So I hope it is clear to all of you. So now let us move to next question. So in next question, here we have a line passes through the point x1, y1 and h, k. If slope of the line is m, then show that k minus y1, this is equal to m times h minus x1. Okay. So this question is for homework. Okay. So this problem is your homework. So do this question in your as a homework. Okay. So that's all for today's session. So thank you very much.